Hello, welcome to another episode of Learning sCrypt tutorials. In this video, I'm going to show you how to do loops in sCrypt. So, different from many other programming languages, smart contract languages, when they do loops, they have to be finite. Otherwise, you can have infinite loops, like in many other languages that have for loops or while loops, such as Java or C++ or JavaScript. So what's the problem here? If you want allow infinite loops, some attackers can send some transactions containing infinite loops. So miners, they can be DDoS in this way. So in sCrypt, to prevent this attack surface and to avoid infinite loops, all the loops, they have to be bounded at compile time. So how does that look like? So again, we start from official website homepage for sCrypt, sCrypt.io. So we click on documentation here. And then under language specification, we click loops. So this is the syntax we see here. So you can see it's denoted by the keyword loop. And then right afterwards, you have to denote the so-called maximum loop count, the number of loops you want to have for the bodies of this loop. So for example, in here, we show a loop 10, and inside this body, we have x equal to x times 2, basically double it. So this is, you can think about as a syntactic sugar. It will be expanded, or in some terminology is unrolled to the equivalent of repeating the loop body by 10 times. So we end up having this. So let's look at some other helper functions that offered by sCrypt loops. The first one is so-called induction variable. So if you're coming from many other languages, a lot of time when you are inside the loop, you want to access the index of the loop. For example, if you have the zeros, or if you have the first, or if you have the fifth, so it's very handy. So we offer this induction variable denoted by colon, and then immediately followed by a variable name. So basically, in this case, for example, I is it's a loop index for the outer loop. So in the first loop is 0, in the second is 1, in the third loop is 2. Same for j here. There is a loop induction variable for the inner loop. So you will loop from 0 to 3. This is just a very convenient wrapper for people who want to access the loop index. So also, how do you, because we don't have a for loop or while loop here, how do you do conditional inside the loop? Again, you have the same function body, loop body, but you can place your condition at the top level of the loop body. So for example, you want to make sure the x is never is always smaller than 8, so you can place it here. Same thing, you can also implement a breaking statement. So basically, you have a flag indicating whether the loop has terminated or not. So if it's not, you keep doing. If you have terminated, you just do not go into the loop body anymore, which is essentially what the break is doing. So lastly, after we talk about the syntax, we want to talk about in practice, how do you usually set the maximum loop count? So this has to be done at a case-by-case scenario because there's no automatic or generic way to achieve this. It all determines the nature of your loops. So for example, if you want to compute the factorial of, let's say, 11, and you only loops, let's say, 5 times, obviously this is too small, right? So you end up having the wrong answer. So if you want to say factorial of 12, you have to multiply at least 12 times, right? If you set smaller than that, you will not get the right result. So this is one issue if you set it too small. So what's the issue when you set it too big? Because some would argue I would always set it to be conservative. I want to set it to always like 1 billion. Of course, you can do that, and in many cases you'll get the correct result. But the issue is, remember, when we send transactions containing smart contract instance onto the blockchain, we have to pay for it, and the fee is proportional to the size of the smart contract. So the larger you set this number, the bigger in general, the bigger fee you have to pay. So you want to set the loop count not too small, so you get the wrong result, nor too big, so you end up paying much more than you expected. So there are many ways. For example, if in some cases you may know the outer bound because based on the computation you are going to do. For example, you may want to see how many zeros are in let's say SHA-256 hash, because you know the hash is 256 bits. So you know the upper bound is, if you want to check the number of ones, 1 bit in this hash number, you can set the bound to be 256, right? And in some other cases, it's not obvious, but you know the range of inputs or all the inputs to this loop you're going to see. So in this case, one way would be you can try all the possible inputs off chain, just for example locally or in some other cloud service. You can compute all you can calculate the number of loops for each input, and then you decide to set it to be the maximum of all the ones you choose the maximum to be the bound. So in this case, basically you run a equivalent version off chain and use the maximum value as a conservative bound here. So okay, I will stop here. I think this is a very unique feature of sCrypt control flow. So I want to just to show how loops is done. So thank you, and I will see you in my next video.